So carbocation react in two different ways. Number one, if I just take this carbocation, so it is reacting in two different ways. Number one, first, it is formation of bond with nucleophile, formation of bond with nucleophile, or alternatively it can react so within the ionic system only, and so releasing or taking up electron from adjacent hydrogen to form alkyl, taking electron from adjacent hydrogen to form a double bond, or we can say loss of alpha hydrogen. This is also known as 1,2 elimination. So this is also example of 1,2 elimination. So let us have a look on this, how this is happening. For example, we can if I have taken this C positive and we have a lot of nucleophiles, like simple nucleophile, if I just say like Nu minus, so what happens is this is donating pair of electron to form a covalent bond, and thus we are getting the product like this, CNU. Or the other way around, if we have this C positive and another carbon with hydrogen on this, so this is donating its electron to carbon minus H plus, and thus it is forming C double bond C, like this one, C double bond C. So this is the basic pattern of reaction shown with carbocation. Let us illustrate this with some more example. If I would have taken this one, like just take ROH plus HBr. So in this particular case, what happens initially is, this is again electron rich center, or we can say this is alcohol, and here it is electron deficient H plus Br minus. So this lone pair of electron, so here this lone pair of electron is donating electron to H plus, so it is forming ROH2 positive. ROH2 positive, and then there is loss of H2O minus H2O, so it is forming R positive now. Now this R positive is electron deficient, and here is Br minus, so it is attacking on this R to form RBr. So this is the alkyl bromide formed in the reaction. So here we can see, like, this is alcohol reacting with acid or Lewis acid to form a carbocation. So initially we have alcohol, here it is carbocation, and here is the reaction between with the nucleophile. This Br minus is a nucleophile which is reacting with this R positive. So here is the product. So in this step 1 is generation of carbocation is here, and step 2 is reaction with nucleophile to form the product. So this is one of the example. If I replace R using this one, suppose I have taken this one, like just take this particular example. If I would have taken CH3 CH3 CH2 OH and HBr, so major product would be P. So this P is major. Predict the structure of P. So what is the structure of P? So this is quite simple, because in this particular case what we can write or what we can see here is the moment we have alcohol, it is donating electron to H plus, so it is forming CH3 CH3 CH2 OH2 positive. So there is loss of H2O, so it is forming CH3 CH2 positive CH3. Now hydride shift. This hydride is being shifted to this one, so generating a carbocation at this particular center, and then Br minus is reacting at this particular carbon, and finally the product would be like this: CH3, it is CH3, here it is CH3 and Br. So this is your major product of this particular reaction. Secondly, if we have the example like this, second one like this, if I would have taken the same alcohol, but I am changing the reagent to this one, CH3 CH3 CH2OH and H3PO4. So here we have to realize, like in case of H3PO4 there is no nucleophilic reagent, though PO4 3 minus is present, but that is not to be considered as nucleophile. And so in this strongly acidic and non-nucleophilic medium, let us see what happens. So we can write this in this particular case in this way. Initial step, again this reaction H plus, so it is forming CH3 CH3 CH2OH, 2 positive, generating a carbocation CH3 CH3, then CH2 positive. Now the hydride migration from this to form CH3 CH3 positive. So we have two different carbocations, and since there is no nucleophile, therefore it is leading to two different product, one and 2. So first, and here it is second, and thus since there is no nucleophile, so what happens is there is loss of alpha hydrogen to the carbocation. So the alpha hydrogen for this is this particular hydrogen, and thus it is leading to the following alkene like CH3, C, double bond CH2, CH3. And in this case again this could be either this or this or this, but all of these will result into the same kind of alkene. So CH3 double bond CH2. So irrespective of the carbocation, the kind of product formed in this particular case is similar, that is the step through step 1 or step 2, the isobutene is the major product, and thus we can say the pathway for the major product is the, no doubt it is taking place through most stable carbocation, and thus the major product would be CH3, CH3 double bond CH2. So this is the major product of this particular reaction. Now when there are multiple centers or multiple type of rearrangement possible, so this is to be remembered that in this elimination it is always most stable alkene, is the major product, So this is to be remembered, and it's very, very important. And so let us have some other example like this. If I would have taken this one, methyl hydrogen, here it is methyl and here it is OH and H3PO4. So what is the major product? Again the process would be similar, and thus we can begin with this one, like initially generate the carbocation as we have done earlier as well. So it is generating this positive charge on OH 2, so here it is methyl hydrogen, and now it is OH2 positive, here it is methyl. Now this is lost to generate methyl and hydrogen. Here is carbocation. This hydride is shifting here to form methyl carbocation, and here it is methyl. Now where is the most stable alkene? So how will you identify most stable alkene? Is the one which has maximum alpha hydrogen, or which is following Sergeff rule. So in this particular case we can have either alkene formed on this, so it is leading to different alkenes like this. The first one is this one, double bond methyl, and here is methyl, and the second one is like this. One more possibility is there, that is this one. So out of these three products, we can see here, this is first, this is second, this is third. So out of these three, in this case, number of alpha hydrogen is 2 here, 2 here, and 3 here, and 3 here. So 2, 2, 4, 3 and 3, 6. So it is 10 alpha hydrogen. 10 alpha hydrogen. In this case, it has 2 here, 3 here, and 1 here. So it is 2, 3, 1. That is 6 alpha hydrogen. And in this particular case, there is 2 and 1. So it has 3 alpha hydrogen. So out of these three situations, we can say this is the most stable one, region being it has 10 alpha hydrogen. So this is what the basis of Sedgwick rule as well. Most stable alkene is the major product of dehydration of alcohol or the final reaction of carbocation in which there is loss of alpha hydrogen. So these are the two major type of reaction of carbocation. We'll see to this in detail a bit more when while dealing with the alkyl halide and alcohols.